Hello everybody, welcome to the 9.2 more practice video. I made this to supplement Mr. McConey's videos, especially since we are doing e-learning. I think this would help you the most. So let's take a look at 3 more examples to help you for your practice problems that you're going to turn into me later today. So when I'm asking you to identify the holes, X-intercepts, domain, and vertical asymptotes, the first thing you'd like to do is factor this completely so you can see all these items more quickly. So the numerator factors to be x minus 4x plus 2. The denominator, you can take out a GCF of 2x, and if you do, you're also left with x minus 4. And that is your new f of x function if simplified. Now, even though it's extremely tempting to cross out the x minus 4's right now, I would like to really push that you always find your domain first, because domain is the only thing out of these 4 that you find before you cross anything out. So I'm going to make a list. I'm going to find domain first, then I'm going to find the holes, then I'm going to find the x-intercepts, and then I'm going to end with the vertical asymptotes. So your domain depends upon your denominator. And so the values that we can't have right now, sorry about that, the values we can't have right now are 0 and 4, because if you set these pieces equal to 0, that's what would cause your denominator to be 0. So I'm going to write a note that x cannot be 0 and x cannot be 4, which means my domain would be the following: negative infinity to 0, union 0 to 4, union 4 to infinity. Now that I've found the domain, now I can cross out the x minus 4's. And as soon as I cross out a common factor, that leads me to the fact that I have a hole in the graph. And that hole, the x value, has to do with what you crossed out. If your factor is x minus 4, that means that your x value is actually 4. So we have the x value, but we need to find the y value. And to do that, we are going to plug the 4 into the reduced version of my function. And the reduced version is x plus 2 over 2x. So if I take that 4 and I plug it in here, that would be 4 plus 2 on the top over 2 times 4 on the bottom, which would be 6 over 8, which reduces to 3/4. So your hole is 4, 3/4. So if you graphed it, there would be a place the graph does not exist at that point. Your x-intercepts are found by what's left over in the numerator. So the only x-intercept I have is x equals negative 2, because you set this equal to 0. So your x-intercept would be negative 2, 0. Now, as another point that I'd like to make that was said in the video, but I think it's good to hear twice, is a point can't be a hole and an x-intercept at the same time, because a hole is something that doesn't exist and an x-intercept is something that does exist. So if you have something cross out, it cannot be an x-intercept as well. My vertical asymptote represents the value that you cannot have. Originally, we had that x cannot be 0 and 4, but we said that 4 led to a hole, so the vertical asymptote is what's left over in the denominator, and then if I set this piece equal to 0, I would get the vertical line x equals 0. So as a little summary here, the domain you always find first, the hole is what you cross out, the x-intercept is what's left in the numerator, and the vertical asymptote is what is left in the denominator. Let's take a look at a couple more examples to see if I can make this more clear. If we take a look at the second one, my first goal again is to factor this so we can see things more easily. If I factor the numerator, I can take out a GCF of x. If I look at the denominator, the first thing I can do is take out a GCF of negative 4. I would suggest taking out the negative so that you have a positive leading coefficient when you divide it out. So you'd have x squared minus 2x, remember you're dividing by negative 4, minus 3. So that would be x times x minus 3 on the top, and the bottom would be negative 4. And this can continue to factor to be x minus 3, x plus 1, because you're multiplying to be negative 3 and adding to be negative 2. Again, before you cross something out, and it's really tempting to cross these out, you would like to find the domain first. And the domain has to do with the values you can't have. So according to the denominator, x cannot be 3 and x cannot be negative 1, which means my domain can be everything else but those values. So it would be negative infinity to negative 1, union negative 1 to 3, union 3 to infinity. Now that we found the domain, now we can cross out the repeated factors, and that leads to what holes we have. And only one thing crosses out, so our hole is going to be 3 comma something, and it's 3 because you set x minus 3 equal to 0 in your head. To find the y value, you plug the x value into the reduced function. The reduced function right now, after crossing this out, is going to be an x on the top and a negative 4 times x plus 1 on the bottom. And so I'm going to take the 3 and plug it in every time I see an x. So we have 3 over negative 4 times 3 plus 1. So that's really 3 times, or 3 over negative 4 times 4, which would be negative 3 over, or positive 3 over negative 16, or negative 3/16. So again, if you graphed it, this point in the graph would not exist. The next thing we'd like to find are the zeros or the x-intercepts. You can say either one. If you would like to find the x-intercepts next, that's what's left in the numerator. So if we look at our reduced version of the function, we just have an x left in the numerator. So if you set that equal to 0, you get 0. So your x-intercept is 0, 0. And the vertical asymptote, the line you can't cross, is what's left in the denominator. This piece right here is going to be your vertical asymptote. If x plus 1 equals 0, it means the line I can't cross is really negative 1. So this again is what's left in the numerator, and this is what's left in your denominator. The last example. Again, I'm going to factor this to make it more simple. So in the numerator, I notice I can take out an x first, left with x squared plus 3x minus 4. In the denominator, I can also take out an x. If I do that, well, actually, not just an x, I can take out a 2x. If I do that, I'm left with x squared minus 1x minus 6. I'm not going to cross anything out yet. I'm going to keep factoring. So the top would be x plus 4, x minus 1, and your denominator is GCF of 2x. Continue to factor. This trinomial would be x minus 3, x plus 2. So before we do any crossing out, we are factored completely, so my domain has to do with my values I cannot have in the denominator. This time there are 3 values I cannot have. X cannot be 0, x cannot be 3, and x cannot be negative 2, which means my domain would be the following. It's everything but those 3 numbers. So negative infinity to negative 2, union negative 2 to 0, union 0 to 3, then union 3 to infinity. Now that the domain is written down, now I can cross things out. None of these cross out, but I would like to point out to you that these pair of x's cross out. And if that pair of x's cross out, think about what value would cause these x's to be 0. Well, if you cross out just an x, the value that makes this 0 is 0. So if you'd like to find a hole, we have 0 comma something. To find that something, we need to plug that 0 into the reduced version, which I will write over here. The reduced version of this, if you cross out the x's, would be x plus 4, x minus 1 on the top. The bottom has a 2 out front, and then x minus 3, x plus 2. So now, if I take 0 and plug it in every time I see an x, I would get 4 times negative 1 on the top, and I'd get 2 times negative 3 times 2 on the bottom, which would be negative 4 on the top, and negative 12 on the bottom, which reduces to 1/3. So your hole is the point 0 comma 1/3. The zeros or x-intercepts is what's left over in the numerator. And I mean, let's again look at our reduced version after we cross things out. So again, the domain's the only thing that you find in the original factored version. Everything else is found from the reduced version. So the x plus 4 and the x minus 1 is left in the numerator. So your x-intercepts would be negative 4 comma 0 from this, and 1 comma 0 from this piece. And the vertical lines you can't cross is what's left in the denominator, which the 2 has no x, so it doesn't really count towards the vertical asymptote. But the other vertical lines you can't cross would be x equals 3 from this piece and x equals -2 from this piece. I hope these three problems are helpful to you before you try the practice problems online, which you'll be turning into me. I will give you feedback on those and answer some questions about them in our Google chat tomorrow. All right, guys, thank you.